Buongiorno baddies, welcome back to another video. So today's only question is, suppose that x is a repeating decimal of the form 0.k with a bar, where k is an n-digit number for some positive integer n. For example, if k equals 238, then n is 3 because there's 3 numbers repeating, and x equals 0.238 with a bar. Show that x equals 0.k repeating, which also equals k over 9.9 with an n amount of 9s. So, as I've done in previous videos, we need to let x be 0.k. Because usually when you're solving a word problem, they give you like a stature for 0.k, but right now we don't have one. So we're just going to say it's 0.k with a bar. So 0.k with a bar. And since we are trying to pull out the k by itself so you can subtract easier, we are going to be multiplying by how many digits that the k is repeating in. However, we do not know what that is right now. But it's already told us that it's going to be an n. So usually when we are trying to solve this, like if you had 0.9 with a bar, then you're going to multiply by 10, which is 10 to the power of 1 because there's only one digit repeating. If there's 2 digits, then it's 10 to the power of 2. But right now we have 10 to the power of n because we do not know how many digits they are, but we call it n because the problem told us to. So we're going to get, after multiplying by this n, this mysterious n, we will get k.k with a bar. So now we're going to, let's just say this equation is 1, this equation is equation 2. We're going to use equation 2 to subtract equation 1. And 10n to the power of x minus x would also be equivalent to 10n minus 1 divided by x. Well, that is a very, very sloppy x. X, which is also equivalent to k. And as you can see, we're already starting to go a little bit down this road of making the same equation with this equation. So now that, since 10 to the power of n is equivalent to 1, 0 with an n amount of zeros, when we subtract 1, 10 minus 1, we get 9 9 with an n amount of 9s. So with this idea on the x side, to try and get something that we can isolate x with, we now have 9 with an n amount of 9s, x, which is equivalent to k. And since we are trying to isolate x like we would have usually in a problem, a word problem or a straight up problem, we have no idea, but this is a proving problem, so we're just going to disassociate that for now. But we're trying to solve for x. Just imagine that you're trying to solve for x so we can prove it. So x would then be equivalent to, since we both sides divide by 9s with an amount of 9s, we would get ... Oh, that is not a dot, that is a line. ... 9 with an n amount of 9s. So doesn't this, well, since this already gives it straight to us, that is this part of the equation, but this we just proved also equals that. So this means that we have officially proved that this equation is also equivalent to this equation. Hurrah! And this is like the end scene if you're like trying to look for the important thing and only looking at my thumbnail. Yeah. So yeah, that's the end of this video. I hope you guys enjoyed and I hope you guys learned something new, and I will see you guys on the next one. Goodbye. Salut. Au revoir.